So what we're going to do in these lessons is we're going to apply what we learned in previous lessons. So remember, in previous lessons, we talked about um, types of transformations. We looked at vertical transformation. We looked at translation. We looked at horizontal translation. We looked at reflection across the x-axis. We looked at reflections across the y-axis. We saw what happens to the points, how to transform the points. We even looked at vertical stretching and compression, and then horizontal stretching and compression, and how that affects certain coordinates of the points. So you may want to go back and review these lessons and say what each of these notation looks like in terms of the type of transformation and in terms of the coordinates. All right, so those were in previous lessons. So just go back to Canvas and review those lessons if you need to. What we're going to do here, though, is we're going to break this part into two parts because each one, what you have to do is, given the function symbolically, you're going to have to graph each transformation that occurs. We're going to have to discuss each part. You have to graph each part and so on. So it's not that difficult. You just got to remember your transformation rules and how to apply those. Okay. Now, in order to graph these, so this will be part one, and this is going to be part two. So we're going to do part one first. So when graphing functions symbolically, so when it's given symbolically, you have to follow a certain order. Okay, and here's the order. So these are the steps for multiple transformations. So here's the order. So the order is, if you have a horizontal translation, you do it first. So remember, horizontal translation is where you had your function, your basic function, your parent function, and you're adding some number to it or subtracting some number from it. Okay, so that was your vertical trans. So that right here is a vertical translation. The horizontal translation is where you have the number on the inside. So something like this. So that'll be a horizontal translation. So x plus c, x minus c. All right. So those are your vertical and horizontal translations. You do horizontal first. You do vertical last. Okay. So these translations, those are the first ones we talked about in our lessons, the horizontal and vertical translations. So you do the horizontal translation first, you do the vertical last. Okay? All right. And then if there's any stretching or shrinking, you do it next. So stretching would be where you have a number other than 1 on the outside of your function, or so that there'll be a vertical stretch compression, or you could have a horizontal stretch compression if the number that you're multiplying x by is something other than 1. All right. And then you do that next. Then you do the reflecting. So remember, we talked about reflecting over the x-axis. We talked about reflecting over the y-axis. So you reflect it over the x-axis, you're going to see a negative on the outside of your function, your basic function. And then reflecting over the y-axis is where the variable x is negative. Okay? And then you do your vertical translation last. All right, so that's the order. Okay, so let's do number one. So number one, now listen carefully how we're going to do this. So you'll notice that in some cases you have your function written in function notation, and then it's just the letter y. It's no big deal. It's just that sometimes you'll see it one way, sometimes you see the other. You have to be able to deal with the situation you see in front of you. Okay, so let's go ahead and write number one. So I'm going to go ahead and write number one. So here's number one. So number one, we want to eventually graph y equal. So we want to eventually graph y equal. So this is part one, letter A. So y equal x plus 7 squared minus 3. All right, so listen how it needs to look. So notice that you first of all have to determine what your parent function is, your parent or your basic function. So I need you to tell me what is the basic function or the parent function. Same thing. So in previous lessons we talked about that. So your parent function, what's your parent function here? It's x squared. So it's your squaring function, right? X squared. So my parent function will be y equal x squared. All right, so we're going to graph that first. Now be a little bit careful. So as we graph each transformation in the coordinate plane, these graphs represent different equations. So in the end, whenever you graph this final one, you're going to name it y equals x plus 7 squared minus 3. So what I want you to do in these cases is call your basic function y1. All right, so let's do that. Let's call it y1. The next one will be y2, y3, and so on. Okay? All right, so let me go ahead and take a grid paper out. And so let's start doing this. All right, so what you got to first do is graph your parent function. All right, so you got to remember, though, in our previous lessons, what x squared looks like and what points we used. So as you do your transformation, those points become very important. So just if you need to use a t-table, so xy, so maybe I should have put that here, so xy. So when x is 0, 0 squared is what? 0. So remember that? So then we would plot that point 0, 0. Okay, and then the next one, remember, we said 1. If x is 1, what's 1 squared? 1. All right, so then we plot the point 1, 1, and so on, right? Negative 1 times itself is positive 1. 2 times itself is positive 4. The next one was negative 2 we used. Negative 2 times itself is positive 4 also. We did 3. Negative 3 times itself is 9. And then negative 3 times itself is 9 as well. And so those are the points you use. And so every time you have a squaring function, use those points, because you're going to be doing stuff to those points. So you need to know what those points are. All right, so we're going to label those points. So we have 0, 0. Well, not label, we're going to put a, if you label it, it becomes messy. Just put dots. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and then 3, 9. Okay? So this is, so you're gonna graph your parent function, so you can graph your parabola. Do the best you can with making it look like a good parabola. And so you get something that kind of looks like this. I'm doing the best I can with this. So you have something that looks like this. All right? And so you're going to say this is, you have to say this. You got to say this is y1 equal x squared. All right, so say that. All right, so the first thing you do is you graph your parent function. Okay, so then we're going to use our rules now. So remember your rules. So you got to go through that order of your rules. So you must go through this order. All right, so if you look at your function, do you have a horizontal translation? Yes, you do. So see how that 7 is under the squaring function? All right, but you got to think counterintuitive, right? So you got to remember that. So remember, you're not going to say 7 units to the right. You're going to say 7 units to the left. All right, so remember your rule, and you may need to go back and review this from the lessons. But if you look at your horizontal translation right here, see this is x plus 7, so x plus c. So that's a horizontal translation, and you go to the left c units. All right, so every point, now notice what's happening. Notice what I'm doing, and you need to do that. So every point on this graph is going to move 7 units to the left, and so you need to say that. So here are your steps. So step 1, what's this? You graphed the basic function. Graph the basic function. And you called it y1 equal x squared. So say it. Graph the basic function, y1 equal x squared. Step 2. Step 2 is where I start using these rules. So the horizontal translation, I have that. So step 2, now watch what I'm going to write. So step 2 says I'm going to shift this right here, this graph, which I called it this. So I'm going to shift y1 equal x squared to the left 7 units. Now I need for you to do this. I need for you to tell me what equation that represents. So that equation is now this. y2 is going to equal x plus 7 squared. And so that's what I'm graphing next. I'm graphing x plus 7 squared. So I'm graphing this part right here. This part right here. So that's my horizontal translation. Watch the pen stroke. What happens? This is what you would do. You take every point that the main points that we use, you take every point and you move it 7 units to the left. So watch. 1, 2, 3, 4, 5, 6, 7. So there's my new vertex. This one right here. So I'm going to go ahead and darken the ones we use. So we use this point, this, this, and this. Remember your t-table? Okay. So then you go here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. See how easy this is? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then over here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so every point is shifted 7 units to the left. So it's kind of like saying this. So you're taking your parent function, you're shifting it 7 units to the left. That's what you're doing. See that? Okay. So then you just draw your problem, just like this. And then what I need for you to do, though, is tell me what that equation represents. So you must say, this is my y2, and that's going to equal x plus 7 squared. Okay? Now, finally, what we want to do is now we're going to take this and do what to it? What are we going to do? We're going to do that next transformation you see, which is that vertical translation. So notice I don't have any stretch or shrink, right? And the reason is because the coefficient out here is 1 and the coefficient of x is 1. So I don't have any stretching or shrinking. I don't have any reflecting because you don't see a negative and you don't see a negative. Okay? But you do have a vertical translation because you do have something on the outside of this function. So remember, if you have something on the outside, see f of x plus d, that's a vertical translation. So, and it's actually intuitive in that case because -3 means you go down 3. +3 means you go up 3. All right, so then in this case, I'll go down 3. All right, so what you're going to do next is you're going to say step 3. So I'm describing. Remember the direction said describe, right? So I'm describing what I'm doing, and then I'm drawing each part. So I'm describing what I'm doing. So now I'm going to take this. I'm going to take this now. I'm going to shift it down 3 units. So remember what's happening is this. So every point will be shifted down 3 units. 1, 2, 3. So my eventual graph will look like this. All right? Okay, so you got to say though, you got to describe. You must describe. So shift y2 equal x plus 7 squared down 3 units. And when I do that, I'm now going to get this graph. So now we have y equal x plus 7 squared minus 3. So that's what I end up having. All right, and all you do is this. Just do what I'm about to do, and you're done with number 1, with letter A. So every point, down 3 units. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then you just draw your graph. And when you do that, just like this, and when you do that, you say now this is y equal x plus 7 squared minus 3. Okay? So as we go through this, notice you can do every transformation. You can do your basic function, and then you're going to do your transformations. And you're going to describe them. You're going to describe what you're doing, just like you learned in previous lessons. You're just putting it all together. And then as we go through this, you just name it. Don't say why, because your as you go through your descriptions, these are different graphs. So you're going to say my first graph is this, my second graph is this, and then the third one's what I wanted to eventually do. So I'm just going to call it what I called it earlier, y equal x plus 7 squared minus 3. All right, so that was letter A. Let's look at B. So B is this now. So here's B. So B, I want to graph y equal negative 4 square root of x. Y equal negative 4 square root of x. All right, so just like we did in the previous part, we need to first of all determine what our basic function is. Because remember, the directions does say describe how the graph of each of these functions can be obtained from a basic function, and then the graph of the function. You want to draw the graph of each transformation that occurs. All right, so we're on this one. So what is my basic function? So your basic function, or your parent function, you're going to say y1, you're going to graph y1 equal what? The square root of x, the square root function. That's your basic function. And so that's what we're going to do first. Now remember though, and you may have forgotten this, but remember, you can only take the square root of a positive number. So when I do that t-table here, you're going to notice that I'm going to use positive numbers and 0 because the domain is any real number greater than or equal to 0. So you can't take the square root of a negative number and get a real number. So if x is 0, what's the square root of 0? 0. If x is 1, what's the square root of 1? 1. Now what we did was the next one we went to is 4 because I'm trying to get these to be integers, to be whole numbers in this case. And then I'm going to use perfect squares. So the square root of 4 is 2. And then the next one was 9 because the square root of 9 is 3. And then what we did was we plotted those points. And so the square root graph, the square root function looked like this. All right, so we have 0, 0. We have 1, 1. We have 4, 2. And we had 9, 3, right? Okay, so that was that one. So that is y1, which equals the square root of x. I'm going to go ahead and darken these because I'm going to need those. So you see what I'm doing? So those key points here is what I'm going to be using to do all my transformations. So I'm going to darken those 4 key points. All right, now, remember our order. So the first thing I would do is I would do a horizontal translation, then I would do a stretch or a shrink, then I would do a reflection, and then always do the vertical translation last. If you don't do it in this order, you'll be graphing the wrong graph for that function you're interested in if you don't do it in that order. So it must be done in that order to get the correct graph. Okay? So it must be done in that order. So if you look at your function, I have, see that negative out here? So that's a reflection, right? So here's a question though. Is that a reflection about the x-axis or the y-axis? So if it's on the outside, remember that's a reflection across the x-axis. Okay? Reflection across the x-axis. And remember, we talked about these points in previous lessons. We're going to use this to a certain extent, but it does help to understand what's happening. And then if it's on the inside with that x, like negative x, then it's a reflection over the y-axis. All right. So I do have a reflection, right? Now, the absolute value, always take the absolute value. The absolute value of negative 4 is 4. So that 4, though, so is that a vertical or horizontal compression or stretch? Let's just not worry about stretch or compression for right now. But is this a vertical or horizontal stretch or compression? So remember, it's on the outside. It's a vertical. If x here is something other than 1 for that coefficient, like 2x, then that will be a horizontal stretch or compression. All right? So you got to remember in previous lessons, you got to go back if you have to. But so all these are coming together in these problems. So if it's on the outside, we're talking about a vertical stretch or a compression. If it's on the inside, bx, if x be multiplied by something other than 1, it's a horizontal stretch or compression. And so remember, when we did, if you look at this, the absolute value of negative 4 is 4. So that's bigger than 1. So what that means is this. What that means is that it's a vertical stretch since it's bigger than 1. So what that means is that I'm going to multiply each of these y coordinates by a certain factor, whatever that factor is. We're going to see it in a little while. Okay? So whenever you're doing a vertical stretch or even a vertical compression, doesn't matter. You're going to notice that the x value stays the same as the y that changes. The x value stays the same. It's the y that's going to change. The x value stays the same as the y that's going to change. And so you may remember that when we did a vertical compression or shrink, you'll notice right here, this one right here. So you notice that the x value stayed the same as the y that changed. And how do you get the y value? You multiplied it by a. Whatever a was, you multiply y by that. All right, so listen to our discussion now. So this then is I want to transform this point. So 0, 0 becomes what point? Well, so remember the x value stays the same as the y that changes. So I take this y value, which is 0, and I multiply by 4, the absolute value. So remember our steps. We didn't write the steps, so let's write the steps. So step 1 is to graph y1, which equals square root of x. Step 2, remember step 2, you must make sure you do the order. So we're doing the stretch and shrink right now. So step 2 is do the stretch or shrink. Okay, so since the absolute value negative 4 is 4, and that's bigger than 1, it's going to be a stretch. So that means that every point here is going to go up by a certain factor. All right, so the way you're going to write it, though, is you're going to say this. So step 2 is you're going to stretch vertically y1, which equals square root of x, see how I'm writing it, by a factor of, and your factor is 4. Well, it's right here. Your factor is 4. So by a factor of 4. So what that means is every y coordinate will be multiplied by 4. So 0, 0 stays 0, 0 because the y value is 0, and what's 0 times 4? 0. Okay, here, see this y coordinate's 1, right? So the point 1, 1, so I want you to remember this. So let's do the thinking on this side. So 1, 1 becomes what point? So I take the y value multiplied by 4. So it becomes a point 1, 4 because the x value stays the same. All right, so that's what you're doing. Okay? So I get the point 1, 4. 4, 2 becomes what point? 4 and multiply this by 4 and you get what? 8. So 4, 8, which is here. And so this one right here, this is going to be the point 9, so that becomes a point 9, 12, but I don't have enough room, so I'm not going to worry about plotting that one. So this right here, you're going to do this now. You're going to draw your function, and this is y2, which equals 4 square root of x. So that's how you're going to say it. Okay. So then you're going to say this. So you're going to say, so stretch vertically y1 by a factor of 4, and we get y2, which equals 4 square root of x. And then finally I do what? The reflection about which axis? The x-axis. If this was negative, it would be the y-axis. But if it's on the outside, so it's the x-axis. So step 3, reflect and say this, y2, which equals 4 square root of x, about the x-axis. Okay, about the x-axis, and we get what we want. So y equal negative 4 square root of x. All right, so let's do that. So remember, we reflect about the about the x-axis, think about what's happening. So every point here, I'm going to reflect about the x-axis. So remember, if I take this point reflected about the x-axis, notice the x-coordinate stays the same. What changed? The y-coordinate. 4 became a what? -4. And that's what that rule says. So when you reflect about the x-axis, remember the x-coordinates stay the same as the y value that changed. It became its opposite. Okay? So 0, 0, the y value is 0. The opposite of 0 is still 0, so that stays here. 1, 4 becomes what point? 1, -4. And then 4, 8 becomes what point? 4, 8 becomes the point for -8. I'll go ahead and just move this up a little. So 4, -8. Okay? And then you just draw your graph, and this right here is y equal -4 square root of x. Okay? So this is what the final graph looks like. So you did your transformation to get this. Notice I didn't use that t-table to do this. You use transformations. You must use transformations. So it says use transformations to do this. So you graph your parent function, then you do your first transformation, and then you do your next transformation. All right, now remember how we got that first one, just kind of a review here. So remember, we stretch this graph by a factor of 4, right? So make sure you understand what that means. See how this distance right here from the x-axis, because remember, when you stretch vertically, you're moving it away from the x-axis by a certain factor. So I want you to notice this. So see this distance is 1? 1 times 4 is 4. That distance is 4, right? See how this distance is 2 units? 2 times 4 is 8. That's 8 units. Okay, so that's what's happening. You're stretching these distances by a factor of 4. All right? Okay. And then, so that was letter B. Okay, so that was letter B. All right, let's look at C. So in C, we have this. We have this problem in C. Okay, so in C, we have h of x is equal to 2 square root of -x plus 3. Okay, now I need for you to look at C and D. So the way we do C, you're going to do the same way we do D. So don't let the way that D looks symbolically confuse you. We're going to talk about that. So be a little bit careful when we get to D. But let's look at C first. So C, remember, you have to use your order. So do I have a horizontal translation? Yes, I have a horizontal translation. Okay. Now remember, for horizontal translation, you got to think counterintuitive. So don't say 3 units to the right. You say 3 units to the left. Okay. Do I have a stretch or shrink? Yes, right here. Since that number's other than 1, and it's on the outside, it'll be a vertical stretch. All right. Do I have a reflection? Yes. I have a negative here. So the question becomes, is that a reflection about the x-axis or the y-axis? If it's on the outside, it's the x-axis. If it's with the x, it's a reflection about the y-axis. And do I have a vertical translation? Is there something on the outside you see other than 0? Nope. So there's none. So there's only 3 transformations you're going to do here. You're going to do the horizontal, a stretch, and a reflection. Okay? All right. So again, the first thing you're going to do, though, step one is you're going to graph the basic function. Okay, so always in every problem, you can do that same wording. Graph the basic function and then name it. Y equals the square root of x. Okay, and then on your graph paper, you use those 4 points. And it's easy to remember them because you know you're dealing with square root, right? And we tend to want to make things easier ourselves, so we use perfect squares. Now, 0 is not a perfect square, but we always use 0 because we can't take the square root of 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. So we get the 0.42, and the square root of 9 is 3. So we get the 0.93. So this right here is the first thing you would draw. So that's y1 equal square root of x. Okay, and I'm going to darken these because I'm going to need these as we go along. So darken those 4 points, those 4 key points that we used. Okay, so that was step 1. Then we're going to do the horizontal translation. So then step 2, you're going to say this. You're going to say shift y1 equal square root of x to the left 3 units. So remember that's a horizontal translation. That's our horizontal translation. All right, so here's what you do. So you're going to shift it 3 units to the left. So watch how easy this is. And you're going to do this on and by the way, make sure you have grid paper, because if you do it by hand, like if you were to draw, if you were to draw this by hand, it makes things so much harder yourself, and then you won't get all your points because it's not going to look very well. So don't do paper and pencil. These graphs, these grids are in Canvas, so make sure you print what you need. And if you don't have a printer, you need to go to Walmart or someplace, Office Depot, and get graph paper. Don't do this by hand. Having an actual grid paper does help you understand it better. Okay, so we're going to move every point 3 units to the left. All right, so that's my horizontal translation. So 1, 2, 3. See that? 1, 2, 3. 1, 2, 3. 1, 2, 3. Now be careful. Just make sure you're doing it right, because there are times when I'll mess up and put the dot in the wrong place. So make sure you're pointing in the right place. 1, 2, 3. Double check if you need to. So this right here is, and you're going to say this is y2, which is the square root of x plus 3. All right. Make sure you put 3 on the inside. Don't put 3 on the outside, because remember that's a vertical translation. So be careful. It's got to look like this. Okay, and then I'm going to darken these because I'm going to need those in a little while as well. All right. So that was our next part, and then we get y2, which equals square root of x plus 3. Right, now, step 3. So step 3 is where you do the stretch or the shrink. Now, since this is absolute value 2 is greater than 1, that's going to be a stretch. So basically what that means is that every point you're going to move up by a certain factor. In this case, it's a factor of 2. Okay? So remember, with the vertical stretch, the x-coordinate stays the same as the y-coordinate that changes. Okay, so step 3. So you're going to say stretch vertically, y2, which equals square root of x plus 3, by a factor of 2. All right, now remember what that means. What that means is that all these y-coordinates you're going to multiply by 4. So this point, so remember, let's look at this one. So the point 1, 2. So think 1, 2 becomes what point? So the x-coordinate stays the same, so that'll be 1 here. The y-coordinate you multiply by your factor. So 2 times 2 is 4. All right, so that's what's happening. So watch my words in my pen. So this point here, so the point 1, 2 becomes 1. You take this, multiply by 2. So remember, you're looking at distances here. So this distance is 2 units, so now it's going to be how many units? 4. Okay? This distance is 1 unit. You double it, you get 2. So the point 1, 1 becomes 1, 2. 0, 0, the distance here is 0, so it stays 0, 0. I'm sorry, negative 3, 0, right? Over here, 6, 3 becomes what point? 6, 6, right? So you're doubling this distance. So 6, 6. And so this right here, you're going to say now is y3 equals 2 square root of x plus 3. 2 square root of x plus 3. Okay? So that's what you say there. Okay? I should have used a different color, but that's okay. And then finally, and let me go ahead and write this right here. So this is now y3 equals 2 square root of x plus 3. Okay, so I'm almost there. So now I got to do the reflection. So that's a reflection across the y-axis. So remember, when you reflect across the y-axis, notice the y-coordinate stays the same. The y-coordinate stays the same as the x. That changes. So when you reflect across the y-axis, 3 becomes a what? Negative 3. And so that's what that rule says. So you reflect across the y-axis, notice your y values stay the same. The x's are now opposites. Okay? All right. So you're going to take this now. So in words, remember you got to say your description. So step 4, you say all these. Step 1, step 2, step 3, step 4, step 5, whatever you need. So notice you do it like this. Step 1, make sure you have your thoughts. You got to explain your thoughts. So step 4, you're going to say reflect y3, which equals 2 square root of x plus 3, about or over or in about the y-axis. And then we get this. We get our function that we wanted to get. So now instead of saying y4, I'm going to call it this because that's what I want now. So we reflect, we're going to get this. H of x is equal to 2 square root. When we reflect across the y-axis, x becomes negative x, so negative x plus 3. Right? And so that's this. So watch, every point is going to reflect across the y-axis. So listen, see how negative 3 is on the left side? It's going to be now where? On the right side. So it becomes negative, so it becomes a point negative 3. Negative 3, 0 becomes a point 3, 0. Okay? And then the point negative 2, 2 becomes what point? 2, negative 2, right here, okay? Then the point 1, 4 becomes what point? Negative 1, 4. So that's right here. Negative 1, 4, right here. And then the point 6, 6 becomes what point? When reflected across the y-axis, this comes here, becomes what point? Negative 6, 6. So negative 6, 6 is right here. And so now you have this. Let me make sure I go through. See how it's getting a little messy? So just be careful the points you connect. All right, and so that is what you wanted to graph. So h of x equal 2 square root of negative x plus 3. Okay? All right, now, listen, it's important you understand, especially with what we're about to do next. See how this right here is this, and those kind of look different? You may say, well, they look the same, right? No, it doesn't. You got to be careful the order in which you do this. We're going to talk about that. So what you may want to do is kind of verify real quick, and you can do that very quick. You can see if this graph actually matches this. So always check, especially when it gets complicated like this, where you have a lot of things happening. Check those points. So watch. So on my final graph, the point 3, 0 is there, right? So let's check it. If x is 3, what's the opposite of 3? Remember, your negative x means the opposite of x. So what's the opposite of 3? Negative 3. What's negative 3 plus 3? 0. What's the square root of 0? 0. And what's 0 times 2? 0. So what's my y value? 0. Let's do the next one. 2, 2. So if x is 2, what's the opposite of 2? Negative 2. What's negative 2 plus 3? Positive 1. What's the square root of 1? 1. What's 1 times 2? 2. So my y value is 2. Let's do this one. Negative 1, 4. So if I plug in negative 1, I better get 4 back, right? What's the opposite of a negative 1? The opposite of a negative 1 is a positive 1. What's 1 plus 3? 4. What's the square root of 4? 2. What's 2 times 2? 4. Now let's check this one. So if I plug in negative 6, I better get what? 6. What's the opposite of a negative 6? 6. What's 6 plus 3? 9. What's the square root of 9? 3. What's 3 times 2? 6. So this and this matches up. And you're done. That is C. So see, it's not that bad. It's actually easy to deal with. Okay. Now let's look at D. Okay, so you got to listen carefully to this, to D. Okay, so in D, you have this. You have k of x is equal to 2 times the square root of negative 1 times x plus 3. Okay, so listen carefully. Some students mess up by looking at this first. So they'll say, I'm gonna take the square root of x and I'm gonna shift it 3 units to the left, because remember you can think counterintuitive. Well, if you do that right away, you're graphing a different function. What you have to do is distribute first. You must rewrite it to where there's no parentheses in here. Okay, you must rewrite it. You must rewrite this first. Must rewrite first. And what I mean by this, k of x is equal to square root of negative x minus 3. Okay? So now, you remember how I said some students are going to say, I'm going to take the square root of x and shift it to the left 3 units? You're getting a different graph than what this is supposed to be. What you do now is see how this now looks like this one? That's what you're going to do. So first thing you do is always rewrite to where there's no parentheses. That's important. Rewrite to where there's no parentheses. Okay, now, step 1. All right, now that's important because if you don't do this, you're going to mess up. You're graphing a whole different function, and that's where in the end, remember I told you always double check to make sure that those points match up with your function you're saying it is. Okay? It helps. Okay, step 1. So step 1, you're going to say graph the basic function. Always say that. And we're going to say y1 equal square root of x. Okay? So we all know what that looks like. We did in the previous 2 problems. And so we're going to have 0, 0. So 0, 0, 1, 1, 4, 2, 9, 3. And then we connect those. And so this is y1 equals square root of x. I'm going to darken these key points here because we're going to need those. All right. Then let's look at what we have. So look what you have. So you have a stretch, right? You have a reflection, and this is a reflection about the y-axis, and then you have a horizontal translation. You don't have a vertical. Okay. Now, remember, according to our rule, we have to do which of those first? The horizontal. Okay, so remember, horizontal, you got to think counterintuitive. So don't make the mistake and say I'm going to move this 3 units to the left. It's not. You got to think counterintuitive for horizontal. So you can move 3 units to the right. Okay, so step 2. Step 2. So you're going to shift this graph right here, y1, which equals square root of 3, 3 units to the right. Okay, and when we do that, we're going to get y2 equals the square root of x minus 3. That's how you write it. All right, so we're going to take all these points, we're going to shift it 3 units to the right. Okay, so watch. 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 3. And I guess we can still do this one, although I ran out of room here. So 1, 2, 3 about here. And so then I connect those, and I get something that looks like this. And this right here is y2 equals square root of x minus 3. Okay? Square root of x minus 3. All right. Now, make sure I say this. So, okay, I got that. Now, step 3. So now step 3, what do I do? So do I do a stretch first or do the reflection? I do the stretch. So step 3 is you stretch, and this is 2. So the absolute value of 2 is 2, so that's greater than 1, so it'll be a stretch vertically. So stretch vertically. And we'll have one that's stretched, that's vertically shrunk in the next Yeah, in the next problem, in the next part 2, in part 2. So stretch vertically, stretch, I misspelled stretch, S-T-R-E-T-C-H. So stretch vertically, y2 equals square root of x minus 3 by a factor, remember you got to say factor, of 2. By a factor of 2. All right, so what that means, remember what that means is that you're taking all these points, oops, here, the red wheel, on this one now, we're taking all these points here and you're moving them up by a factor of 2. All right, now be careful because you don't move this one because this is 0 right here, the y value. So remember what you do is you take the y values multiplied by a factor of 2. So you see right here, that distance is 1. 1 times 2 is 2. So this point becomes what point? That point. So remember, you're taking the y value multiplying by 2. So this distance on the x-axis is 0, so 0 times 0 is 0. So the point 3, 0 becomes what point? 3, 0. Right? So 3, 0. So I'm going to go ahead and do this. Okay? The point 4, 1. So remember, we got to think. We have to think. So let's think. 4, 1 becomes what? So remember, if you stretching vertically by a factor of 2, that means you multiply the y coordinate. That means multiply y coordinate by c. So remember right here, whenever you stretch vertically or you compress, you multiply the y coordinate. They use the letter A. In our lessons we use C, but that's okay. So you multiply by that number. Okay, so that becomes what? 4, 2. 1 times 2 is 2. Okay, so I'm glad the point 4, 2. It kind of makes sense because when you stretch vertically, see how this point is 1 unit from the x-axis? So now when I stretch, it will be 2 units. Okay? So I'm using green here. The point here, 7, 2 becomes what point? 7 what? 2 times 2 is 4. So you see how this is 2 units? It becomes 4 units. And then over here, that was, let's see, we moved it 3 units. That was 9, 10, 11, 12. So 12, 3 becomes 12, was that 6? Make sure it's right. So, because I didn't have enough room, remember? So it was this point right here. So we moved it 3 units. So 9, 10, 11, 12. So 12. So 12, 3 becomes 12, 6. So right here. And so you connect those and it looks like this. Oops. So we reflected okay, so that was a shifting. Okay, I'm sorry. I thought I had done the reflectors. Oh Lord, I already messed up. Okay, so that is the stretching. Okay, so that is y. So we stretch vertically, so we get y3 equals 2 square root of x minus 3, right? So we call this y3. So y3 equals 2 square root of x minus 3. Okay. Now we're going to do what? We're going to do the reflecting across the y-axis. So step 4. So we reflect what we just did, y3, which equals 2 square root of x minus 3, across the y-axis. Now remember, when we reflect across the y-axis, see this point here? When we reflect across the y-axis, the y value stays the same. What changed? It was the x-coordinate. They became opposites. All right, so you got to think like that. So when you have the grid, always visualize it. Always visualize what you're doing. So then I'm gonna go ahead and use a blue graph for that one. So then remember we're reflecting the green one now. So the point 3, 0 becomes what point? Negative 3, 0. The point 4, 2 becomes what point? Negative 4, 2. The point 7, 4 becomes what point? Negative 7, 4. And then this one was what? It was 12. I keep forgetting what that one is. 12.6. So 12.6 becomes negative 12.6. So somewhere way up here. Somewhere around here. So then we get this. All right. And that is the graph I wanted to graph. So I'm going to call this now, this right here. So k of x is 2 times the square root of, and it doesn't matter which one you use. I'm just going to use the original one. So negative 1 times x plus 3. So that's what this is. All right. Now before you go on, double check, because you could have messed up somewhere around here. So here are those points. So let's just do these 3 points. You can use this one as well, but you didn't have to because it was off the grid. But check it. Okay, so if x is negative 3, watch what happens. If x is negative 3, we want the y value to be what? 0. So what's negative 3 plus 3? 0. What's negative 1 times 0? 0. What's the square root of 0? 0. What's 0 times 2? 0. So you get a y value 0. Let's check this one. When x is negative 4, I need a y value of 2. What's negative 4 plus 3? A negative 1. What's a negative 1 times a negative 1? A positive 1. What's the square root of a positive 1? 1. What's 1 times 2? 2. Let's check this one. So if x is negative 7, I need my y value to be 4, right? What's negative 7 plus 3? A negative 4. What's negative 4 times a negative 1? A positive 4. What's the square root of 4? 2. What's 2 times 2? 4. And if you want to do negative 12.6, you can. What's negative 12 plus 3? A negative 9. What's negative 9 times a negative 1? A positive 9. What's the square root of 9? 3. What's 3 times 2? 6. So it matches up. You're done. So you did a good job. That's what you do. Okay? All right, so let me make sure I did the description. All right, so we reflect y3, which equals this across the y-axis, and we get, make sure you say this, and we get our function k of x, which equals the 2 square root of, now remember when you reflect across the x-axis, the x becomes what? Negative. So negative x minus 3. Okay? All right. So that's the end of this part. Now what's going to happen is, so that was part 1. So we couldn't do all this in one video because it takes too long. But make sure you go back over this before you look at the next video dealing with this. So in this one, we're going to look at absolute values, and we're going to look at a cubing function as well, and a square root. So again, go over this before you look at this. So you are going to need to know how to describe, how to do a transformation of these functions and graph it. And make sure you do it just like we did. It must be done like this. You got to have your steps. Step 1, step 2, step 3, and so on. And notice at every point I used y1, I used y2, I indicated what the expression was, what the equation is. I used y3, and our final one, whatever your last step is, you're going to write whatever that function was. Okay? All right, so that's how you do this. So make sure you do it just like we did. So that's going to take care of this lesson. Remember, this is where we were describing how to graph a function using transformations and then draw each transformation.